Hello, Assalamu alaikum, greetings and welcome to Learning Economics. Also welcome to our series Data Analysis using R. Dear viewers and listeners, it is rare that a data analysis involves only a single data frame. Typically, we have many data frames and we need to join them together to answer the questions that we are interested in. Our today's video discusses this in detail. For understanding these mergers or joins, we must need to understand what are primary and foreign keys. Dear viewers and listeners, every join involves a pair of keys, a primary key and a foreign key. A primary key is a variable or set of variables that uniquely identifies each observation. That is, it has a unique value for each observation. When more than one variable is needed, the key is called compound key. For example, let's go on the RStudio screen and see. But before that, I would request you to subscribe to this channel if you have not subscribed yet. And do give a thumbs up to our video if you really like them. Show us what you really like or what topics you want us to make a video on in the comments. So over to RStudio screen. So here we are on RStudio screen, and as let's see the New York flight data. As you know, if we have not downloaded this package which contains this data, we have to download it. Otherwise, we can just call it to the library. Since we have already used it in multiple videos earlier, so I have already had downloaded this data set and it was covered in some of the previous videos as well. So now if we look at airlines data, for example, so yes, so we have a table of 16 rows and 2 columns. First variable is carrier and then is name. So it records the piece of the data about each airline, such as its carrier code and its full name. We can identify an airline with its two-letter carrier code, making carrier code as the primary key. Similarly, let's see what we can identify as a primary key in the airports data. So for that, I'm writing airports, and here we have a table of 1458 rows and 8 columns. Here you can see FAA. This is a 3-digit code that is given to each airport name, and uh, this makes FAA as primary key. So we have other, for example, LAT, LON, longitudes and latitudes are, and TZ, DST, destination, T zone, etc., other variables. Similarly, if we see the planes data, for example, let me write it over here, planes. Now we have 3322, yani 3,322 rows and 9 columns. We have tail number, year, type, manufacturer, models, etc., speed, engine, etc. And you can see in the seat, the values are repeating. You can see engines repeated values. You can see in models repeated values, manufacturer repeated values. But in the tail number, the values are unique. As we can see, at least up till 10 rows, these are not repeating. I will cover how we can make it sure throughout the data I mean through all the rows, but till now, let's just focus on what is visible in front of us on the screen. So up till at least 10 rows, there is no repetition in the tail numbers. So this actually tells us that this is a unique number, so it is a primary key. Now, what is foreign key? Dear listeners and viewers, foreign key is a variable or a set of variables that corresponds to primary key in another table. For example, the tail number in flights data, which we can write as, is a foreign key that corresponds to primary key tail number in planes data, written as this. Note, this writing style is not related to primary or foreign key. It is generic and can always be used to refer a variable in a specific data frame. Let's see on the RStudio screen once again. So here we have planes data, and we can see that the tail number is uniquely identified here. But if we see the flights data as well, as year, month, departure time, etc., and more variables are given here. And here you can see the tail number. So we can match the tail number from the our primary data with the tail number in this secondary data. This makes the difference between the primary key and foreign key. Similarly, if the carrier in flights data is a foreign key that corresponds to primary key carrier in airlines data. We can see that carrier is a key in flights data. Similarly, if we have seen the airlines data, let me just check. Yes, we have seen the airlines data, and here you can see that there is a key carrier, and it is uniquely identified. In a very same way, in the flights data, origin variable is a foreign key that corresponds to the primary key FAA in the airport's data. So this makes the difference between primary and secondary key. Now that we have identified primary key in each table, it's a good practice to verify that they do indeed uniquely identify each observation. That is, they do not repeat within the dataset. One way to do that is to count the primary keys and look for the entries where n, the number is greater than 1. So for that, let's go again to the RStudio screen. To save the time, let me just copy and paste the code over here. And by this time, we have already covered all these functions. And you very well know that n is for counting or for the number. So we are filtering the tail number column. We are counting it and then filtering uh, those values for which the number is greater than 1. And sorry, for this, I first need to call tidyverse to the library. So let me call it. Yes, the tidyverse has been loaded. So now we can use this pipe function. And it says that there are 0 rows and 2 columns. 2 columns are tail number and n, but for those where n is greater than 1, there is no such column there. So throughout the data set, the tail number does not repeat. So here I am covering the point which I just paused a little while ago, that just look at first 10 rows and see if there is any repetition. And I told you I will come back to tell you how to check for all the rows. So this is one way to check for all the rows that we first create a number n which counts the repetitions and then filter these values by n greater than 1. And if there is no value, that means uh, there is no entry in this variable specifically which is not unique. So every value repeats only once, and this fulfills the condition for being the primary key. Similarly, we should also check if there is any missing value or not. So for that, let's filter it if there is any missing value. So we use function is.na, and again, it has 0 rows. It means there is no row that has NA in it. So in this way, we can check for the primary key. If there is a compound key, that is, there are more than one keys that uniquely identify and that collectively make the primary key, we need to check for the greater than one for in the both as well as uh, .na function as well. So here we are using this symbol, which is a symbol for OR. It means if there is an NA in time R, it should filter it out. Or if there is an NA in origin, it should also filter it out. We have covered these functions in our earlier videos. So again, we can see there is no such row. So this is how we check for the uniqueness, which is a must for the primary key. So now that we have learned about the primary and foreign key, it's the time to learn how join works. We shall be focusing on how each row in a data frame called X matches with the rows in another data frame, say Y. We shall use visual representations of join to help better understand the underlying process. And for the practice, we shall use a single key and we shall call it as key, and a single value column, value X and value Y in each of these data frames. But the ideas are generalizable to multiple keys and multiple values. We are using small data frames purposefully so that we can observe what is going on. The process will remain same even on the large data set. So with these explanations, let's go to the RStudio screen and create a simple and short data frames, namely X and Y. Okay, so let me create two small data frames, X and Y, and to save the time, I'm just copying and pasting the command over here. This is we are creating X, and this we are creating Y. And as you can see in the command, we have created two columns in our data frame X with 3 observations in each column. First column names key 1 to 3. Second column names val underscore x, value of x. And you know now very well that when we write within inverted commas, it is a character variable. And in the second data table, we have the same key variable, but the other variable is VL, that is value of Y. And again, that's a character variable. The key is the common variable over here in the two data sets. So this will be used as primary as well as foreign key. For the first data set, it will be the primary key. For the second data set, it will be the foreign key. So now let's first see the inner join. And in the inner join, the rows are retained only if and only if the keys are equal. You can see this on your screen in this visualization as well. The dot represents all those values which correspond to same key, and hence those will be the part of the output. So now let's see this on the RStudio screen, and here we shall write inner underscore join. We shall give the primary data frame, that is the first data frame which we are using, which is X. It should be merged with the Y, and using the key here we need to give what is our primary key, and as we know, the variable key is our primary key. So this, and you can see that it matches one with this one. So we have X1 and Y1. The 2 matches with this 2. So we have X2 and Y2. There is no match for 3. There is no match for 4. So those are discarded. This is how we use inner join as merger. After the inner join, there is another join which is called as outer join. Outer join keeps observation that appear in at least one of the data frames, or I mean either in X or either in Y. These join work by adding additional virtual observations to each data frame. These observations has a key that matches if no other key matches, and the values are filled with missing value, that is NA. There are three types of outer join. First is left join. Left join keeps all the observations in X. So you can see its output in this visualization. And again, the dots represent those values that correspond to left join and therefore will appear in the output. Now, on the RStudio screen, let's see how this works. So instead of inner join, here I am writing left join. And now you can see it has retained all the values in X. So 1, 2, 3 are retained, X1, X2, X3. And since the key value 3 is missing in this Y data set, so it has created a virtual row in Y for the key 3, and here the value in the variable Y is missing, so has placed NA. Fine. If similarly, we can use the right join as well, and in the right join, it retains all those rows that are present in Y, and if a row corresponding to a key number in Y is missing in X, it adds a virtual row, and in the value of the column, it places NA, that is missing value. Let's see this on RStudio screen. So here you can see it has retained 1, 2, and 4. 1 and 2 are match. 4 is not a match in Y, so it has placed NA over here. If you want to save this as a new data frame, you can give the name. For example, I say new, and I use this right underscore join followed by X, join X and Y, and join them by key, which is in our case named as key. So now you can see it has created a new data frame, which is new. Let's view it. And you can see a virtual row in X has been added and the value is NA over here. Full join keeps all the observations that appear either in X or in Y, as you can see in this visualization. The output starts with all the rows from the first data frame, that is X here, followed by remaining unmatched Y rows. And on the RStudio screen, let's see it. So we have full underscore join. The two data frames are X and Y, and we want to join them using primary key, which is key. So here you can see it has completed X first, 1, 2, 3, and the third is missing in Y, so it has placed NA. Then it has added the rows from Y. There is only one row which is which was not matching, so the fourth row has been added and NA has been placed for variable for the data frame X. So this is all about today's lecture. In the next video, we shall discuss matching and filtering joins as well as non-equi joins. And we shall also practice on the larger dataset, which is New York flight dataset. So again, I'm requesting you, if you really like our videos, give a thumbs up. Do tell us in the comments what you want us to make a video on, and also tell us from where you are watching our videos. Do share these videos with your friends, fellows, and family members so that they can also get on board in this learning activity. So until the next video, take care of yourself and bye-bye.